Example number 14. A county realty group estimates that the number of housing starts per year over the next 3 years will be the function h of r equals 400 divided by 1 plus 0.03 r squared, where r is the mortgage rate in percent. Where is h of r, that is, where the housing starts increasing, and where are the housing starts decreasing? So I could use the quotient rule here, but I notice that that numerator is a constant and that I have a exponential expression in the denominator, and I can write that to the -1 power. Remember, this denominator is to the 1, so I can move it to the numerator and make it a -1. And that's going to allow me to use the exponent rule. Now I have a power, the power rule. So it's going to be 400 times the power times the base, 1.03 r squared, to the power -1, which is -2, and don't forget the chain rule. So that's going to be times 0.06 r. Cleaning up a little bit, I'm going to get these monomial factors together. I'm going to make that a -400, and I'm going to put the 0.06 r in the front. And I'm going to go ahead and move this to the denominator. 1 plus 0.03 r squared squared. And remember, when you use the quotient rule, you end up with the denominator squared. So there's our denominator squared. I'm going to multiply out the top, -24r, and that is over 1 plus 0.03 r squared, all squared. Now remember, we're talking about a mortgage rate in percent. So we do have a limited domain for h of r. Okay? Our r value has to be greater than 0. It doesn't make sense to have an interest rate on a house that's negative. So our domain here is going to be a rate from 0, and then probably not realistic to say infinity, but we don't have any cap that is known on this interest rate, so we're going to go ahead and say 0 to infinity. Now the next thing I have to do is take a look at my derivative. By the way, I should label this h prime of r. Okay, so this is my derivative right here. And that's the answer that they want in this first blank. Now I'm going to look at the sign of this thing, and I'm going to be looking from 0 to infinity. Well, all of these are positive numbers because they're all bigger than 0. So this top has a negative times a positive. So the numerator is going to be negative. And I can pick a number and plug it in, but I can just go ahead and just generalize. Because of this square in my denominator, this denominator is going to always be a positive. So that's over a positive. So a negative over a positive is always a negative. So that means that our original function, h of r, is always decreasing, because if we pick any test point or we generalize, we're going to get negative for that derivative. So we would say that h of r, the housing starts, are never increasing. Housing starts just mean how many new houses are being built. Okay, and the function is decreasing for rates from 0 to infinity. So in other words, no matter what the rate is, there's going to be a decline in housing starts.